today's class, let us learn how to solve pair of linear equations in two variables by algebraic methods. In my last video, I have explained how to solve a pair of linear equations by graphical method. Here I go by solving using algebraic methods like substitution method and elimination method and many more. Okay. Sometimes graphical method of solving is not convenient, like situations you will get where the points are like say root 2 comma 3 comma root 3, something like this, or you may get the points like minus 1.75 and 6.6, or in terms of fractions say 1 by 3, 1 by 19, something like this. In such situations, plotting need not be accurate and there is a possibility of going wrong. So to overcome from this, we go by algebraic methods. First method is substitution method. I'll explain with the problem first and then we'll go by understanding it in terms of theory. Suppose you have a pair of linear equations, say 2x plus y equal to 6 and 4x minus 2y minus 4 equal to 0. You have to solve this pair of linear equation. First, what you have to do is these two equations you have to rewrite in such a way that one variable is written in terms of other. Now when I take this equation, I'll call this as equation 1, this as equation 2. I'm naming them. I'm rewriting equation 1 as, say, I'll just take up 2x to this side, y equal to 6 minus 2x. Now I'm substituting this y value in equation 2. Substitute this y value, y equal to 6 minus 2x in equation 2. Equation 2 is 4x minus 2y equal to 4 or minus 4 equal to 0. You can write it in any way, no problem. Now I have to replace y by this. So I'll rewrite 4x minus 2 into value of y is 6 minus 2x equal to 4. Now you just simplify 4x minus 12 plus 4x equal to 4. Then 4x plus 4x is 8x minus 12 equal to 4. 8x equal to 4 plus 12, that is 16, and x equal to 16 by 8, it is equal to 2. Now substitute the value of x equal to 2 in any one of the equation, either 1 or 2. Okay, you will get the value of y. Substitute x value, that is x equal to 2 in equation 1 or 2. It's not necessary you have to put in 1 only. You can put either of them. Equation 1. Equation 1 is 2x plus y equal to 6. X value is 2, so 2 into 2 plus y equal to 6. So 4 plus y equal to 6. Y equal to 6 minus 4, that is 2. So it is asked to calculate the value of y, x and y. So you are getting x equal to 2 and y equal to 2. So step 1, I'm just explaining. Step 1 is to find the value of one variable in terms of other. Writing y in terms of x or x in terms of y. You just have to rewrite any one of these two equations. It's not necessary that I have to take up first equation always. Okay, you take any one of them and get the one variable in terms of other variable and put it in the other equation. Okay, so first step is to find the value of one variable in terms of other, and the second step is substitute that value in the other equation. Okay, and solve them. That's all. But while solving, you may come across the situations like suppose you have this situation. Say you have problem like this: 2x plus 3y equal to 9, and you are getting 4x plus 6y equal to 18. Okay, suppose this is the situation. This is a pair of linear equation. Now you have to solve them by substitution method. I'm just rewriting this equation. 2x equal to 9 minus 3y. This is equation 1. This is equation 2. Now x equal to 9 minus 3y by 2. Now I'm substituting this x in the other equation. X equal to 9 minus 3y by 2. I have taken this equation first, no? So in other equation I have to substitute. In this equation 2. Equation 2 is 4 into x plus 6y equal to 18. X is 9 minus 3y by 2 plus 6y equal to 18. Now we're getting like this: 18 minus 6y plus 6y equal to 18. These two will get cancelled. You are getting 18 equal to 18. I'm sorry. Yeah. So that's what I'm saying. Sometimes when you go for substitution method, you may come across to this situation. This is the situation. See, in this case, you are getting left hand side equal to right hand side. So this statement is true for any value of y. It's irrespective of the value of y. I can give y equal to 0, 1, 2, whatever. So this is such situation where you are getting two equations are same. If you are getting like this, the statement is true, right? So in this case, we are saying two equations are equal, are same. You can observe even just by looking at these two. If I multiply this whole equation by 2, what happens? 2 into 2 is 4x. 2 into 3 is 6y. 2 into 9 is 18. You are getting it like this, right? So these two equations are same. So if you multiply the equation 1 by 2, you are getting the second equation. So in this case, we are saying equations have infinitely many solutions. Therefore, equations have infinitely many solutions. This is only in those cases where you are getting left hand side equal to right hand side after substitution. Okay, there may be other situations like this. So this is example 2. I take up one more example 3. Say solve by substitution method. Equations are x plus 3y equal to 6 and 2x plus 6y equal to 18. This is another situation. So this is equation 1. Equation 2, I'm rewriting this equation, x equal to 6 minus 3y. Substitute value of x in equation 2. Equation 2 is 2x plus 6y equal to 18. X, I'm writing it as 6 minus 3y plus 6y equal to 18, and this is 2 into 6 is 12 minus 6y plus 6y equal to 18, and the 6y will get cancelled with this, right? I'm getting 12 equal to 18. Is it true? No, right? This is false. So you can say that two equations have no solution. If the statement is false, then you can directly write no solutions or no solution for this pair of linear equation. You got the point? You have to check every time. You have to write one variable in terms of other and then go for substituting. But when you go for substituting, you may come across the situations, these three situations. First situation, on substituting, you are getting a variable value or value of the variable, and then you can proceed to get the value of another variable. This is where the situation where you are getting a solution. And in the second situation, you may come across with situations like this. And in those cases, you can write there are infinitely many solutions. And the third situation is where you are getting a false statement and you can say that there is no solution. So we'll take up one more problem. That's a statement problem. You have to write it in terms of equations and then you have to solve by substitution method. Okay. 7 years ago, father was 7 times as old as his son, and 3 years from now, father's age is 3 times as old as his son. Find their present age. So let father's present age be as, say, present age is x years. Okay, and son's age is, say, y years. Okay. Now first statement is 7 years ago, father was 7 times as old as his son. 7 years ago. Present age is 6. So x, 7 years ago means x minus 7. That is equal to 7 times as old as his son. 7 years ago, what is the age of his son? That is y minus 7. I hope you got it. 7 years ago, so therefore x minus 7 for father, and for son it is y minus 7. What was the relation? 7 years ago, father was 7 times as old as his son. Right, so 7 into son's age, that is again ago 7 years. So it's 7 years ago, therefore y minus 7. That's the first equation. And then 3 years from now, father's age is 3 times as old as his son. 3 years from now, so I'm just adding 3 years to the present age, even for the son. How many times? 3 times as old as his son. So 3 into y plus 3. So second equation. In both the equation I can rewrite x minus 7 equal to 7y minus 49. So x minus 7y equal to minus 49 plus 7. So it's minus 42. I'll call this as equation 3. And this x plus 3 equal to 3y plus 9. So x minus 3y equal to 9 minus 3, so it's 6. Equation 4. So I have to solve this by substitution method. Now I'll just take up this equation and I'll rewrite it. X equal to 7y minus 42. Now substitute this x value in equation 4. Equation 4. Equation 4 is x minus 3y equal to 6. So x value is 7y minus 42 minus 3y equal to 6. 7y minus 3y is 4y and 6 plus 42. So 4y equal to 48 and y equal to 12. That is, son's age is 12 years. Right. Now I have to substitute value of y equal to 12 in any one equation, in equation say 3. In equation 3. Equation 3 is x minus 7y equal to minus 42. So x minus 7 into 12 equal to minus 42. So you simplify for minus 42. So again 8. 88. So it's again 42. So father's age 42 years and son's age is 12 years. You can cross check with your answers because it is mentioned 7 years ago. 7 years ago means 42 minus 7. This should be equal to 7 times the son's age. Right? These two should be equal. If they are equal, these two should be equal. If they are equal, then your answer is correct. Always go for rechecking. Okay. I have few set of problems to solve. These are 4 problems. You have to solve by using substitution method. Thank you.